Today we'll be going over the Unit 5 test review for Algebra 2. There are a number of different types of problems on here. We'll begin with numbers 1 and 2, where we're finding the inverse of each of these functions. There are 4 steps I want to take. Step 1, let's change f of x to y. So this will just read y equals 2x squared plus 3. Then step 2, I want to solve for x. So this means get x alone. Let's subtract 3 from both sides. So we've got 2x squared equals y minus 3. Divide both sides by 2. X squared is equal to y minus 3 over 2. And take the square root. So x is equal to, and I'll leave this as the square root of y minus 3 over 2. Once x is solved, step 3 is to swap x and y. So any x that I see will become y, and any y that I see will become x. So this is now going to be y equals the square root of x minus 3 over 2. And this is your inverse. So all we need to do for that last part is swap y to f inverse of x to show that, yes, this is the inverse of what I started out with, f. So let's do that with problem number 2. F of x equals x to the third minus 4. So step 1, change this to y. Y equals x to the third minus 4. Step 2, let's solve for x. So let's add 4 to both sides. X cubed is equal to y plus 4. And then we'll take the cubed root of both sides. So x is equal to the cubed root of y plus 4. All right, then step 3, we're going to change x to y and y to x. So this will read y is equal to the cubed root of x plus 4. And lastly, make y f inverse, because this is the inverse of function f. So cubed root of x plus 4 is our answer. Okay, for the next few problems here, we've got describe the transformations of g of x from the parent function f of x equals the square root of x. Then down here, I've got the cube root of x down here as well. And then it looks like for numbers 3 and 5, I've got a 4 and 6 where I'm going to need to find the domain and range as well. So what I'm going to do, let's begin by finding all of the transformations, and then I'll go back and find the domain and range for number 3, and then find the domain and range for number 5. So starting with number 3, g of x equals the square root of negative 1/4 x minus 2. Well, firstly, this negative on the inside, as part of this multiplier, negative 1/4 x, this is going to tell me I'm going to have a reflection. Because this is on the inside, this is a horizontal reflection. So I'll begin there. I've got a horizontal reflection. And then the 1/4, because this is on the inside again, this is horizontal, it's kind of the opposite of what I would think. Instead of shrinking this down to 1/4 the size, this is actually going to be a horizontal stretch of 4. And then lastly, this minus 2 at the very end is a vertical change. This will be a shift downward of 2. right, number 5. For number 5, I've got g of x equals 5 times the square root of x, and then plus 4 at the very end. This 5 on the outside at the very front is a multiplier. This will tell me that this is a vertical stretch of 5. And then the 4 at the very end tells me I'm going to be shifting up 4 units. Number 7, I've got 1/2 at the very front of this cube root of x minus 6. So this 1/2 again is a vertical change, tells me that there's a stretch or compression. Because vertical changes are more intuitive, this is going to be a vertical compression of 1/2. And then this minus 6 on the inside, I'm subtracting from x. So normally I would think subtracting from x, let's go left 6 units. But because this is horizontal changes are the opposite of what I would normally think. So this is going to be shifting to the right 6 units. And then number 8, I've got the cube root of negative 3 times the quantity x plus 1, and then minus 2 at the very end. So we got quite a few transformations. Let's begin with this negative. The negative times, negative 3 times x plus 1 on the inside, this will tell me there's a horizontal reflection. All right, next. 3 on the inside as a multiplier. This is going to be a compression, remember opposite, of 1/3. So I've got a horizontal compression of 1/3. Then adding 1 to x tells me opposite, shift left 1. And finally, minus 2 at the very end. This is going to be a vertical translation. These are intuitive. I'm going to shift down 2. Now that we've got all the transformations, let's go back and find the domain and range for number 3, as well as the domain and range for number 5. So going back to number 3, the square root of negative 1/4 x minus 2. To find the domain, we're going to set the inside of this square root. So the negative 1/4 x, we're going to set that greater than or equal to 0. So negative 1/4 x is greater than or equal to 0. And then I'm going to solve for x. So here, I can multiply both sides by negative 4. So doing that, negative 4 times negative 1/4, those will divide out. And I've got x on this side. On the other side, 0 times negative 4, well, 0 times anything is still going to be 0. But because I multiplied or divided by a negative, this sign has to flip the other direction. So instead of greater than or equal to, I've got less than or equal to. So this is my domain. X is less than or equal to 0. For the range, what I do here is I set the entire square root. So I set the entire square root of negative 1/4 x greater than or equal to 0. And then what I want to do is build up the function so that it looks exactly the same as what g of x is. So I ask, what's missing? Well, what's missing is this minus 2 at the very end. So if I were to give it this minus 2 over here, I would also need to subtract 2 over here. Well, this is the square root of negative 1/4 x minus 2 is greater than or equal to 0 minus 2 is negative 2. Now this is g of x, and that is fancy for just y. So my range is y is greater than or equal to negative 2. All right, number 5. We're going to do the same thing. For the domain, just set the inside of the square root greater than or equal to 0. So x is greater than or equal to 0. And there's nothing to solve for. This is just x. So the domain is just x is greater than or equal to 0. For the range, I set the entire square root here, square root of x, greater than or equal to 0. And I want to build up the function so that it reads the same as g of x. So what's missing? I'm missing a 5 on the outside, so I'm going to multiply this by 5, and I'm going to multiply this side by 5. Okay, so 5 times the square root of x is greater than or equal to 0 times 5 is still 0. And I'm still missing a 4. So I'm going to add 4 here. That means I have to add 4 on the right side as well. So 5 times the square root of x plus 4 is greater than or equal to 4. And because this is the same as g of x, I can now say y is greater than or equal to 4. And that's your range. All right, let's move on to the second page. At the top of the second page, I've got 2 graphs. And for each of these, I want to find the function for the square root and find the function for the cube root graph here and write this in a standard form. Okay, let's begin with number 9. This is a square root function. The standard form is g of x equals a times the square root of b times the quantity x minus h, and then plus k at the very end. So the first thing I want to do is I've got these 2 points here. Let's identify what these 2 points are. This point is negative 2, negative 1. So let's write that down. Negative 2, negative 1. It's right there. And this point is negative 1, 2. Now for the square root functions, I want to say that one point is my initial point, and then the second point I'm just going to call my second point. So the initial point is where this graph starts. It starts here at negative 2, negative 1. And my initial point is always going to be located at hk. So hk is equal to this negative 2, negative 1, which tells me that h is equal to negative 2 and k is equal to negative 1. From there, I can go to my second point, which is h plus 1 over b, and then k plus a. This second point is negative 1, 2. So this tells me that left is left, h plus 1 over b is equal to negative 1, and on the right side I've got k plus a is equal to 2. Well, let's begin with k plus a equals 2. That looks a little bit easier. I know that k equals negative 1. So negative 1 plus a equals 2. If I add 1 to both sides, I'll see that a is equal to 3. The last thing I need to find is b, because I've got a, I've got h, and I've got k. So plugging in h here, I found earlier, is negative 2. This is negative 2 plus 1 over b is equal to negative 1. So adding 2 to both sides, I've got 1 over b is equal to negative 1 plus 2. That's going to be positive 1. So I can write this as 1 over 1, since this is a fraction. And if I were to flip this upside down, find the reciprocal, b over 1, I would do the same thing over here, and that would be still 1 over 1. So this tells me b is equal to 1. Once I find a, b, h, and k, I can go ahead and plug them into the standard form here. G of x is equal to 3 times the square root of b is 1, quantity x minus negative 2, so x plus 2. And then at the very end, plus negative 1, or just say minus 1. For number 10, I'm going to do something similar, except instead of calling this my initial point and then this my second point, the first point is going to be my point of symmetry. Okay, so right here, this is my point of symmetry. What I see going down and to the left is what happens going up and to the right. This point is negative 3, 2. And this point, my second point, is negative 1, 3. All right, my point of symmetry or point of reflection is still hk. So hk, this point is actually at negative 3, 2. This will tell me h is equal to negative 3. And k is equal to 2. Now I can go to my second point, which is still going to be h plus 1 over b, and then k plus a. This second point is at negative 1, 3. So same as above, left is left, right is right. H plus 1 over b is equal to negative 1. K plus a is equal to 3. And let's work with k plus a first. I know k is 2. So this is 2 plus a equals 3. Subtracting 2 from both sides, I'll get a is equal to 1. Over here, h is negative 3, so we'll say negative 3 plus 1 over b is equal to negative 1. So this will give me, adding 3 to both sides, 1 over b is equal to, add 3 here, this will be 2, I'm going to write this as 2 over 1. So when I flip this upside down to make b over 1, or just b, I'll also flip this upside down to be 1/2. b is equal to 1/2. Now I've got a, b, h, and k. Plug them in. G of x equals 1 times the cubed root of b is 1/2. Quantity x minus negative 3, so we'll do x plus 3. And then on the very outside, plus k is 2. Lastly, I've got 4 problems where I'll be simplifying an expression. I want to assume that all variables are positive, and I want to make my exponents, once I've simplified this, to be positive in my final answer. So 11. 2 times x squared over y squared, this is all to the second power. So what I can do with this outside 2 is kind of distribute this to everything and say this is the same as 2 squared times x squared squared over y squared squared. Well, 2 squared is 4. X squared to the power of another 2. A power to another power, I multiply those powers together. So this will be x to the 4th over, same thing on the bottom, y squared, all brought to another power of 2. This is y to the 4th. For number 12, I see that I've got an x on top and an x on bottom. So whenever I see the same base to some power on top, as well as that same base to some other power on the bottom, what I can do is subtract those powers and just say I've got one of those variables. So y will stay the same. This will be y to the 4/9. But for the x part, I've got x to the 1/3 minus 2/9. This is the same as saying y to the 4/9 times x to the, let's make a common denominator, 3/9 minus 2/9. And then, of course, 3 minus 2 is 1. So my final answer, this will be y to the 4/9 times x to the 1/9. 13. Just like I did for number 11, I'm going to kind of bring everything to this power of 2 here. So this will be x to the negative 3 to the second power, y to the 5th to the second power, over z to the 3rd to the second power. So let's do it over here. This will be x to the negative 6 times y to the 10th over z to the 6th. All right, lastly, if I've got something to a negative power, I can just bring it to the bottom or bring it to the top, whichever the opposite of it is. Here it's on the top, so I'm going to bring it to the bottom, and I'm going to make that power positive. So this will be y to the 10th over, the bottom part will read x to the positive 6, and then z to the 6th. And lastly, number 14. Same thing here. Let's bring everything to the power of 3. So this will be x to the 4th to the 3rd power over x squared to the 3rd power, y to the negative 3rd to the 3rd power. Over here, x to the 12th over x to the 6th, y to the negative 9th. And like I did for number 12, we're going to subtract these because I've got x to the 12th over x to the 6th. So I can say 12 minus 6. That's going to be x to the positive 6th over y to the negative 9th. And then because on the bottom I've got a negative exponent, I can just bring that y to the negative 9th to the top and make that positive. So this will end up just being x to the 6th, y to the positive 9th. Hope that helps. Test will be coming up. Please study. And the test is going to look just like this review.